Welcome to another exciting educational video brought to you by Chrysolite Tutors. Today we'll be looking at FMT215, Quantitative Analysis in Finance. And in two of this course, we'll be talking about Arithmetic Progression, AP. AP, I can assure you, it's not a political party. It's known as Arithmetic Progression. So in this course, this topic, we'll be looking at definition, evaluation of AP, application of AP to finance, depreciation, straight line depreciation technique, and we'll conclude. So if you're not subscribed to this channel, please subscribe. So like those of you who are studying for distant learning programs in National Open University and every other part-time programs, this will be for you. And if you just want to upskill and know more about AP, this is also for you. So sit tight. So in this section, we'll be learning about AP series, Arithmetic Progression series, which is one of the special series mentioned in Unit 1. You know, we talked about Unit 1 where we talked about series, writing formulas for different kinds of series. So Arithmetic series is a series in which the preceding term differs from the succeeding term by a constant value. So many financial problems are of this nature. Examples include straight line depreciation and annual salary increment. In such problems, there are three parameters: the initial value, the constant increment, and the number of incur periods. So these parameters will allow you to determine the value of AP at any time, also determine the sum of the AP, and the use of AP model allows you to give a concise solution to problems in finance. So I will quickly start by giving us an example of an AP. So an AP, Arithmetic Progression series, can include something like this: 1, 3, 1 plus 3, plus 5, plus 7, plus 9, plus 11, plus blah 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 to the nth term. Okay, so this is a series. Now, what are the characteristics of this series? What are the traits of this series? Number one, there is a concept known as the first term. A is the first term. A is the first term. First term. And for this particular series, is the number that starts the series is equal to 1. Okay. And there is a D known as the common difference. The common difference is a constant difference between the two terms, preceding terms. So this is the first term, this is the second term, this is the third term. Between this and this, there is a difference. This difference is 2. Between this and this, there's a difference is 2. There's a difference between this and this is 2. Here is 2. You agree with me that 3 minus 1 is 2. 5 minus 3 is 2. 7 minus 5 is 2. 9 minus 7 is 2. So there's a common difference, which is 2. That is one of the characteristics of an arithmetic progression. Okay? And the term, the nth term, is the particular term that contains a value. Okay, so if I look at it now, I say this is the first term followed by the second term, the third term, the fourth term. It's different from the value that it contains. You know, we saw it in Unit 1 that, for instance, if I say locate the fifth term, so I count 1, 2, 3, 4, 5. This is the fifth term, and there's a value inside the fifth term, which is 9. So the nth term is the term in consideration. Okay, consideration. Yeah. Okay. So that's the term in consideration. So if, for instance, now I want to get there's a concept of the sum of terms or the number of terms. Number one, and the sum of terms. Okay, now I have 1, 2, 3, 4, 5, 6. Let's say I'm asked to find the eighth term. So the number of term is given as this: nth term is equals to a plus n minus 1, then d. Okay, so I believe that we've all defined these values, these values, these alphabets. Um, A is the first term, N is the number of terms, and D is the common difference. Well defined. So if we're asked to find the sum of terms is given as Sn is equals to N over 2, open bracket, 2A plus N minus 1, then D, then close the big bracket. So these two formulas are very, very important as we are diving into arithmetic progression series. Okay, so I'll quickly use this one to predict the number of, the nth term of the same series. So if I have 1, 2, 3, 4, 5, 6, 6 terms are visible to me. If I'm told to find the eighth term, find the eighth term, find the eighth term of this series, of that series. So I'll say that the eighth term is equals to A is 1 plus, open bracket, N in this case is 8 because we're looking for the eighth term minus 1. Then D is the difference. The difference is already 2. So we can prove that. We can go ahead and say 1 plus 8 minus 7 minus 1 is 7. So I have 7 here and times 2. So 7 times 2 is 14. 14 plus 1 is 15. So the eighth term is 15. Now if we decide to continue, after 11 I have 13. If I add 2 here is 15. So which is consistent with what we got here with the formula. So this is always used for getting the nth term of the particular series. So we'll dive into other examples and we'll go and apply it to finance. So if you're not subscribed to our channel again, please subscribe to our channel and like this particular video to get to more persons. So I have on the board, evaluate the sum 10 plus 40 plus 70 plus 100 plus 130. We can choose to bring out a calculator and start adding these values, which is still okay. But looking at this series, it's a series because I'm having a plus sign in between. I see that the characteristics of series is in order. The first thing, it has a first term. A is equals to 10. It has a common difference. The difference between the first and the second term, that is a term and a preceding or receding term, is a constant. So look at it. 40 minus 10 is 30. This is a constant. 70 minus 40 is 30. It's a constant. 100 minus 70 is 30. And 150 minus 130 minus 100 is 30. If I try to take it midway, it's the same thing. So the common difference is there. So these two things are very, very important for us to adjoin a particular series, an arithmetic progression. Okay, so but we are now told to find the sum of the terms, the sum of this progression. How did I get n because of 5? 1, 2, 3, 4, 5 terms in this series already. So we have sum of terms, sum of first 5 terms, sum of first 5 terms, which is this. I have A, no, not A. I have n over 2 is equals to 2A n over 2, 2A plus n minus 1, then D. Okay, so this is the formula. So I know that n is 5, so I put 5 there over 2. Then I have a 2a, 2 times 10 plus n is 5 minus 1. Then common difference is 30. So just plug in all the values into the formula. So 5 over 2 times 2 times 10 is 20 plus 4 minus 5 minus 1 is 4 times 30. Okay, so 4 times 30, 0, 12 plus 20, all multiplied by 5 over 2. Okay, so I'll conclude it here. This and this will give me 140. That's 5 over 2 times 140 over 1. 70 is 350. So 350 is the sum of the first 5 terms of that series, which is consistent to when you add each of them one by one with the calculator. But of course, you agree with me that if the series is a very long one, you might not have the luxury of adding up with the calculator. You just go with this formula. So we're going to dive in straight to apply this in finance. Okay, so we'll dive in straight to a practical application of arithmetic progression in finance. I have on the board said Mr. John arranged to pay off a debt of 9,600 in 48 annual installments, which form an arithmetic progression. So this is the final payment he will pay in 48 installments, and the way he's going to pay it is forming an arithmetic progression. Okay, so when 40 of these installments have been paid, Mr. John died and his creditors finds that he has that 2,400 still remains unpaid. Determine the value of the first two installments of Mr. John. Okay, this is quite lengthy, but we need to understand the principle that this operates. First of all, I have the first statement here. It said Mr. John arranged to pay off a debt of 9,600 in 48 annual installments. So, well, given information that it forms an AP. So, the sum of what is going to be paid, which is a sum of the 48th installment, is equals to n over 2, 2a plus n minus 1, then d. This is the formula already. Now, for this particular statement, for 48th annual installment, I have that this money, 48th annual installment, is spread, that this amount is spread across 48 annual installments. So S48 is 9,600. This one is S48. That's the sum of what is going to be paid. And the installments, the number of installments is 48 over 2. That's why I have n as 48. Then the a is not given, plus n again is 48 minus 1. Then d again is not given. So we only have two parameters for the first statement. We have the total amount, which is 9,600 in 48 annual installments. That is number given. So I have an equation here, with two variables missing, a and d. Okay, so I can just make this simplify. I can say 9600 is equals to 12, because 2 will go into, not 12, 24, please. Okay, so when you go to a divide 2, you have 24. So I have outside 2a plus 47. This is difference. Then d. You see how it is? I just simplified this to this. Understand? So 48 cancels. 14 divided by 2 is 24. This remains the way it is. So when I divide both sides by 42, because by 24, divide both sides so that I can remove this one from here, I'll be getting 400 at this side. 400 is equals to 2a plus 47d. 47d. So I'll call this equation 1. I'll leave it like this because I can't simplify further. So, but I know that I need to get these two. What we're going to find is the first installment, A. And the first installment is A, second installment is A plus D. So I have to find these two. Now I'm going to get the second equation from the second statement. It said, when 40 of this installment have been paid, Mr. John died and his creditors find that 2,400 was left. So I'll get S40. I'll get S40. How do I get X40? S40. Now the actual value of S40 is S48 minus 2,400. Why? I'm told that S48 is already 9,600. So at the point where he has paid 40 of it, you understand? Then he died. Now you have S48, that is this one, minus this balance that is left. It will now give you how much he has paid up so far. Okay, so I know S48 already now. So S40 is equals to, S48 is 9,600 minus 2,400. This will give me S40 is equals to, when I do the math, this minus this will give me 7,200. 7,200. So 7,200 is S40. So I can come here and write equation for S40. So S40 can still be n equal to open bracket 2a plus open bracket n minus 1 then d. Please just note how these formulas, get these formulas in your mind. Always call it up. This is the sum of terms in an AP. AP stands for arithmetic progression, by the way. So this is sum of terms. So you know how to marry the statement with the formula. Now S40 is already given as 7,200. N is still given as 40. Why? Because we're looking at a new series of 40. 40 installment. That's a new series. Okay, but inside the series we are considering. So 2a, again, no a given, and the n here is 40. That is 40 minus 1. Then d is not known. So I can break this one down. 7,200 is equals to, this will cancel. That is 40 divided by 2 will give us 20. Then I have 2a plus this minus this is 39d. Okay, so if I divide both sides, I have 720 divided by 7,200 divided by 20 will give me 360. 360 is equals to 2a plus 39d. So this is another equation 2. So you see, I have two equations. I have two equations. So my goal is to solve them simultaneously. Okay, so we have now two equations. So 1 and 2. So we're going to solve them simultaneously. I'm going to bring this one under here. This is, okay, let me just bring the equations. Equation 1 is 400 is equals to 2a plus 47d. This is equation 1, yes. Then equation 2, 2a plus 39d, equation 2. So let's focus on this because all of these crystallize to give us these two. So let's focus on this. So I can subtract. I will just do subtraction of the two equations. So why am I doing subtraction? I want to eliminate this particular one. So I want to eliminate this one. So 400 minus 360 is 40. 2a minus 2a is 0. 47d minus 39d is plus 8d. So I can divide both sides by 8 to get d. This one is already 0. So 40 divided by 8 will give us d is equals to 5. So I've gotten one of them. I've gotten d as 5. What about a? How do I get a? So I can take this side off because I'm done with this side. I just need these final things. I'm done with this side. So I've gotten d as 5. So what is a? I can now say substitute d is equals to 5 in our equation. So let me take equation 2 for instance. In equation 2. So I'm going to write this equation 2 again. This is equation 2, write it again. 360 is equals to 2a plus 39d. Now, anywhere I see d in this equation, I plug in 5 so that I can get a. So that is 360 is equals to 2a plus 39 times 5. 39 times 5 will give me 195. 360 is equals to 2a plus 195. Now, this one will cross. I'll have 360 minus 195 is equals to 2a. So let me do the maths. 360, okay, hold up. 360 minus 195 will give me 165. So I have 165 at this side is equals to 2a. And a is equals to 165 over 2 divided by 2. 165 divided by 2. 165 divided by 2. I'll get 82.5. Now 82.5 is the initial money he paid. So look at the question. Determine the value of each of the first two installments. The first installment A is 82 naira 50 kobo. While the second installment will now be A plus D because D is the common difference. Now look at it this way. Let me take this one off again. I just need my A and my D. All this is just for us to get A and D. So the series is like this: A plus D plus A plus 2D plus A plus 3D, and so on. But my concern is first term and second term. First installment payment and second installment payment. First installment payment is 82 naira 50 kobo. This is it here. 82 naira 50 kobo. Okay. Now second installment payment will now be 82 naira 50 kobo plus 5 naira. So that will give me 87 naira 50 kobo. So we have completed the first, this is the first installment A, and this is the second one. Okay, so I hope this clarifies. Let's go on to the next one. Okay, so with the knowledge we have had so far about arithmetic progression, we are going to dive into depreciation. We have actually seen how we can apply arithmetic progression in finance, and even depreciation is an extension of the use of arithmetic progression techniques. So a very important concept really in business, that's depreciation. Depreciation is an allowance made in estimates, understand, valuations, yes, machine operations or balance sheets normally for wear and tear. So if you have a value of something now, it's assumed that over the years the value will wear down. It will not be the value again after some years. It will go down negatively after some years. Now, it's normally an accounting practice to depreciate the value of a certain asset like machine used during the manufacturing and vehicles used for daily company operations. So we treat this depreciation in two methods of calculating. First of all, we have the straight line method, and secondly, we have the reducing balance depreciation. Okay, so for the straight line method, a constant value is taken away, from the original value at regular intervals. Let's say every year you take away a value. So if sometimes you have an asset that is valued at let's say 34,000 naira. It could be a machine, it could be a vehicle, it could be anything. You understand? Just for purpose of our analysis, we're taking a lower number. You have this amount. Okay, let me make it a round figure. Let's say 100,000. Okay, so let's say every year we say that 10,000 is the depreciation value. Understand? That means you take it away from this original value. So you say for the straight line method, we can now use the formula of AP to calculate the depreciation value with the constant decrement being negative increment. So this one now is a negative increment. So if I have this value, the value as P, understand, the value as P, after the first year, you take away P minus D. So P minus D, this D is this value, like we call it depreciation value. It's a number, or it's an amount. Depreciation value is an amount. So this is the asset value, the initial value. Okay, so after that, this P is the asset, that's the initial value. Yes, the initial value. Okay, so this is the first year. The second year again, second year, you take away 2P and 2D, and third year you take away 3D. It will get to a point where the deductions will stop, because at that point, that's the value of this asset at that point. Okay, you will appreciate this better if we apply this with some practical examples. So after many years, the value of the assets, value of assets of assets. We call that value A. That is the one I said you value of asset after many years, after many years, or after n years. Value of asset A is equals to P minus NG. Okay, so A actually is smaller than P. P is how it started with. A is how it will end after n years. D is the amount, depreciation amount that you will take off every period, every year or every period. Okay, let's look at practical example quickly. Okay, so we have an example on the board. It says a machine was bought for 840,000 naira, which is expected to last for 10 years with a scrap value of 200,000. So that scrap value is the last amount it will get to where it can no longer have any value. Calculate the yearly depreciation value using the straight line method of depreciation. Okay, straight line depreciation. So the formula is A is equals to P minus ND. Just note this. Where A is the scrap value, where A is the scrap value, it's equals to scrap value, and the value it will come to where it can no longer have any use. P is the initial value of this machine. P is the initial value, and N is number of years. In consideration, we have 10 years, number of years, and D, what we're looking for, is the yearly depreciation value. Yearly, that is it's a constant value every year that will be removed. I explained that there's a concept of a value that is removed every year so that we can actually tell that this is what is the wear and tear of that particular item. So the yearly depreciation value, that's the yearly depreciation value. Okay, so here it's simple enough. I have A initial, that's the scrap value. If you don't know anything at all, this A is actually always lesser than P. A is the value, the scrap value, the value it will tend to after some years. So A is 200,000, P is 840,000, N is 10, and D is unknown. So this is what we're looking for. Every other thing here is mathematics. So the finance has stopped. Now here's mathematics. So mathematics and finance, mixed together. So that's not a problem. So I have 200,000 minus 840,000. What happened? Why am I having like this? This one crossover and becomes minus 10D, right? Okay, so if I do the maths here, this way, I'll be having negative 640,000 minus 10D. So if I divide both sides by minus 10, I have minus 640,000 over minus 10 is equals to D. So this will cancel. I have 64,000. 64,000 is the yearly depreciation. So every year you move this amount, so that it will now go gradually until it gets to 200,000. Okay, so I hope this clarifies. Let's go to the next one. So this is another question on the board that we have to consider. It says an employee produced 600 units in the third year of its existence and 700 units in the 7th year of its existence. What is the initial production in the first year if production follows an AP? So once you hear AP, what comes to your mind? There are two kinds of formulas: the number of term formula and the sum of term formula. So for the number of term formula, we can adapt it for this particular kind of case because we are told that this is the number of units and this is the third year. So this third is the third term and this is what is inside that third term. So this is the seventh term and this is what's inside that seventh term. So if I were to write the formula for the number of terms, the number of nth term is A plus N minus 1, then D. This is the formula for the number of n term. Now for the third term, okay, let me call it N3. So for the third term, I have A plus N will now be 3 minus 1, then D. Understand? But I'm giving a value for the third term already. That's 600. So I have 600 here. So I can say 600 simplified into A plus 2D. This is equation 1. Now for the other scenario, I'm given seventh term. The seventh term is seventh term is what do you have as seventh term? Seventh term is 700. Yes, 700. This is it. Is equals to A. Is still having the same what's it called? First term, because it's a series, plus the number of terms there is 7 because it's a seventh term, minus 1, then D. So if I simplify, 700 equals to A plus 6D equation 2. Now, my goal is to find the initial production number. So I'm going to have two equations here. I'm going to solve simultaneously to get A, which I'm looking for. How do I do that? How do I do that? Okay, this is just simply by subtraction. I will subtract 1 from 2, subtracting equation 1 from 2. Subtracting equation 1 from 2, I can rewrite it, put equation 2 up first, 700 is equals to A plus 6D, this is equation 2, and equation 1 is what? 600, A plus 2D, equation 1. So if I rule my line like this and put minus sign here, this 700 minus 600 is 100. This will cancel because A minus A is 0. And 6D minus 2D will give me 4D. So I'm getting D first. So I get 100 over 4 is equals to D because I divide both sides by 4 so I can get D standing alone. 400 divided by 4 will give me 25. So the common difference is 25, but that's not my goal. My goal is to find the first term. That is the first initial production. So where do I go? I can put in the equation. I have equation 1 like this, equation 2 like this. I can put D in equation 1 to get A. So substitute. D is equal to 25 in equation 1. Okay, so this is equation 1. So I have A plus 2D is equals to 600. So A plus 2 times 25 is equals to 600. So A plus 50 is equals to 600 because 2 times 25 is 50. So A is equals to 600 minus 50. When I do the maths, A will now become 550. 550 is the initial unit that is produced. This is it. Let me just take this off. So A is equals to 550. So 550 is the initial unit that is produced in the first year. In the first year. All right. So you see that it's not you just easily just guess that because seventh year there's 700 and third year there's 600. Okay, well I think it's correct where I'm saying it. So we have looked at various things in this topic, very interesting topic. We have seen that arithmetic progression has 3 parameters, namely the first value, which is the first term, and the common difference, which is the noted as D, that's a constant term, and the number of periods denoted by N, number of terms. Okay, so AP is a series in which the difference between any 2 consecutive terms in the series is a constant. It does not change. In the next unit, we'll be seeing where the constant will be changing. We'll see that, but right now, the constant does not change. I mean, the difference of the terms, the difference of the terms of 2 consecutive terms is a constant. The terms of the AP form this particular array. I have A plus D plus A plus 2D plus A plus 3D and so on. Understand? Where is the first term, second term, third term, and so on. Okay, so the sum of terms N is given as, or before I go to sum of term, this one, the nth term, UN term, is equals to A plus N minus 1 Then D, know this formula very well, please. Do not let it escape your mind. Then sum of terms, according to the number of this, sum of terms is n over 2, 2a plus n minus 1, then D, or brackets. All right, so I hope this video has been informative for you. I'd like to thank you for viewing.